Hey guys, welcome back. This is a problem using trig substitution. We know that the integral of 1 over 1 plus x squared dx is equal to arc tan x, but what if we get something like this? What is the integral of the square root of 1 plus x squared with respect to x? Now this problem takes a long time to do, so I wrote out all the steps and I'm just going to walk you through it. In this problem, it almost looks like a arctan. Kind of. We have the 1 plus x squared here. We have the 1 plus x squared here. So what we're going to do here is we're going to let x equal tan theta. We're going to take the derivative of x with respect to theta. So the derivative of x is 1 dx d theta. The derivative of tan theta is secant squared theta. I'm going to solve for dx so that way I can get rid of this part here. So dx is equal to secant squared theta d theta. I'm going to go back and substitute. I make x equal tan theta and dx equal to secant squared theta d theta. So we're going to take the square root of 1 plus tan squared theta times secant squared theta. Well, do you guys remember the identity? 1 plus tan squared theta is equal to secant squared theta. It's one of the Pythagoreans. We'll take the square root of that, and then that's going to become secant theta times this secant squared theta. That's going to become secant to the third theta with respect to theta. What we're going to do here is we're going to do integration by parts. And what I did was I said let the dv part be secant squared because I know how to take the integral of that, which is just tangent. And secant I know the derivative of. So this secant and secant squared makes secant to the third. The derivative of secant is secant theta tan theta. Once you get them into this format, all you have to do is make this little check. It's going to be the product of these two, which is right here, minus the product of those two. Secant times tan theta will make it tan squared theta secant theta. And then what we're going to do here is we're going to exchange tan squared theta for secant squared theta minus 1 because we can't integrate tan squared theta. Once we do that, we're going to distribute this. So secant squared times secant is secant to the third, and negative 1 times secant is negative 1 secant theta. Now, remind yourself that there's a negative out here. So all of these signs are going to switch in a second. There's basically no room here. So let's go to the next page. I have one of the most important things when you guys are integrating is to make sure that you keep the question in play. So the integral of secant to the third theta is equal to tan theta secant theta minus this integral here. So that's from this part here. What we're going to do here is we're going to give the negative to the secant to the third, but then make that positive. So that's why I have a plus sign there. I notice that this is my question. Anytime you guys do integration by parts and you come back to the question, what we're going to do is we're going to add it to the other side. So now I have two of these. Once you have two of these, you could bring down basically the rest of the problem. So this part here is this, and then we have this person here. Well, the integral of secant theta, let me get back my highlighter, is the natural log of secant theta plus tan theta. Tan theta, secant theta, there's no integral sign in front of it, so we're just going to bring it down. Of course, the bell rings. So now we're going to divide by 2. So we get this. Now, you guys have to remember from the last video, the same thing is going to apply here. We're going to have to change all the thetas into x's. So our answer was tan theta secant theta plus the natural log of secant theta plus tan theta. Tan theta from the beginning is equal to x. That's what we set it equal to. Using a right triangle, we're able to say tan theta is opposite over adjacent and then figure out the hypotenuse. And so we just do that and we substitute all this, and that's how you basically do this problem.